Okay, let's continue our discussion about the relationships of f, f prime, and f double prime. I've got here some AP type questions. They're not exactly like we'll see on AP, but they're close enough. They're going to cover the high points. Up here to the left, I have graphs A through D, and they are parent functions. They're going to be f. And down here in the right-hand corner, I have graphs Roman numeral 1 through Roman numeral 4, and they are going to be the graph of f prime. So we're going to look, we'll start with A, and we're going to look at attributes on f and see if we can figure out what the graph of f prime might look like. We know that f prime is going to have a 0 here and a 0 here. We know because f is decreasing on this interval, f prime is going to have negative outputs. Because f is increasing, f prime should have positive outputs there. And again, because f is decreasing, f prime should have negative outputs there. So negative outputs up to our 0, positive outputs in between our two zeros, and negative outputs after that 0. So we're looking for negative, we're looking for two zeros here and here. I see a graph that has two zeros. This one has 1 0, this one has 3 zeros, that one doesn't have any zeros. So really I don't have to look any further, but let's just confirm that the other activity is the same. All the outputs on this function are negative up to this first 0. Then all the outputs are positive in between the zeros, and all the outputs after that are negative. So this definitely is the derivative of the graph that's shown in A. So let's move on and let's look at B. B is a series of linear pieces. There's a line with a constant slope. It's a positive slope. So I would expect that the derivative function would just be some positive line, a constant value, a horizontal line along those x values along the x-axis. Then this next piece, from that x value to this x value, the slope is negative. So I would expect that the derivative function would have outputs that are below the x-axis because those are negative outputs for a function. Here the original function has the positive slope again. It appears to be the same slope as this piece, so it's probably going to be on an even level. So I'm looking for the graph of a function, and I see here in Roman numeral 4 that has linear pieces, two positive and one negative linear piece. One negative linear piece. And notice here that at this x value and at this x value, the graph of f prime is undefined. Well, that should make sense because over here at this x value and at this x value, the graph of f takes a sharp turn, which means the derivative won't exist there. So Roman numeral 4 is definitely the derivative of our function in B. So let's move on to C. Over this interval, f is decreasing, meaning f prime has negative outputs. It has one and only one 0. That's the horizontal tangent line. And from 0 to positive infinity, f is increasing, so f prime should have positive outputs. Well, the only of the two left, the only one that has 1 0 at 0 is this function. So let's see if everything else is true. We have negative outputs up to 0, and we have positive outputs after 0. So Roman numeral 1 has to be the derivative of the function they gave us in C. Now, by default, we know that this has to be the derivative of the function in D. So let's see. We have a 0 on the derivative function there, a 0 on the derivative function there, and a 0 on the derivative function there. And sure enough, this function has 3 zeros. Our outputs on the derivative function are positive on that interval. Sure enough, they are. Negative on this interval. Sure enough, they are. Positive on that interval. Yes, we have positive outputs. And negative on that interval. So this definitely is the graph of the derivative function of the function they gave us in D. So we can tell a lot about landmarks and activity as far as positive outputs and negative outputs on our derivative function just by looking for horizontal tangent lines and monotonicity on our original function. So let's move on to another type of problem that we might see on AP. And here it says the figure shows the graphs of f, f prime, and f double prime. Identify each curve and explain your choices. So let's look here. The best way to identify which function might be f, which might be f prime, and which might be f double prime is to start with zeros. There's a 0 on function A. There's a 0 on function C. There's a 0 on function B. And what I want to do is I want to go up or down vertically from those zeros, and I'm looking for another function. That's an intersection there. There's an intersection there. I'm looking for where a function has a horizontal tangent line. Because when a function has a horizontal tangent line, its derivative will have a 0. So right here, function B has a horizontal tangent line, and function C has a 0. So my first guess, and I don't know if I'm right, I'll have to do more checking, is that C might be the derivative of B. So let's see, if that's the case, then everywhere that B is increasing, C should have positive outputs. Well, we're good so far. Everywhere that B is decreasing, C should have negative outputs. And sure enough, that's true. So I'm going to say that C is B prime. Now, I don't know if C is F prime or F double prime, and I don't know that B is F yet. I need to do some more investigation. So let's pick up another color and let's go to this 0. Because as we go up, A has a horizontal tangent line and B has a 0. Hopefully you can see it with all the drawing that I've done. So my first initial guess here is that B would have to be A prime. So A is increasing from here to here, meaning B should have positive outputs over that whole interval. Yep, that's good. A is decreasing over this interval, meaning B should have negative outputs. Sure enough, it does. So I'm saying that's the case as well. So if that's true, then F has to be graph A. And since B is A prime, that means F prime has to be B. And since C is B prime, that means F double prime has to be C. So again, just like we did on the last set of graphs, we're just looking for landmarks and monotonicity behavior to see if we can figure out which is the original function, which is the first derivative, and which is the second derivative. All right, another AP type question. For the function f, whose graph is shown, arrange the following numbers in increasing order. All right, so we have the number 0 and we have the number 1. Okay, they've already given us 2 numbers. The rest of the things that we need to find are slope of the tangent line at those 3 x values and concavity at that x value. Remember, when we have a grid, the first thing that I want you to do is I want you to find your axes. There's the x-axis, there's the y-axis. I want you, on clues that they've given you, I want you to label your tick marks. Here, it just so happens that all the tick marks are 1 unit apart, but we can't always count on that for every AP problem. So pay attention to the units that they give you. So here, this question says, find the slope on f at x equal 2. So here's x equal 2. Here is the point of tangency. And so we want to find the slope on that point. We don't have to be exact. Okay, this is kind of an approximation. And what we can do is just find a couple of points. We could use that point and that point. We could come up here. We could use this point and this point, just anywhere along in there that's going to give us a good approximation. Probably that right there is the better approximation. So to approximate f prime of 2, I'm going to find the coordinates of each point. That's the point 4, 2. This is the point 0, -1. And I'm going to find the slope, rise over run, through those 2 points. So I have 2 minus -1 over 4 minus 0. So I'm going to say that f prime of 2 is a positive 3/4. All right? Let me kind of get rid of some of this work so we can go on and do the next one. We're looking now for the slope through 3. There it is. We'll draw a little piece of the tangent line. We'll go up till we get a well-defined point. We'll go down till we get a well-defined point. An alternative way of actually doing the rise over run when they give you a grid is to realize that you have all those values right there. Here we go up 1, 2, 3, 4. That's our rise. And we go over 1, 2. That's our run. So the actual slope at 3 is approximated to be 2. So there's an easier way to do it without actually having, unless they tell you to, without actually having to do all that work. When they give you the grid, it makes things a lot easier. So now let's find the slope at x equal 5. So here we are. This slope, I would say maybe there and there might be a good approximation. So this is a rise of 2 and a run of 1, 2, 3, 4, 5. So we'll call that 2/5. Okay, I don't have to be exact. All they asked me to do was to list all of these in increasing order. So that's good enough for me to tell what's increasing. Now this one's a little bit different. Here they want the concavity at 5. Well, clearly it's concave down. But I don't really need to actually find what that value is. I just need to realize that that value is going to be a negative value. And the beauty part is none of the other values they gave me are negative. So now I can do this. Now I can list them in increasing order. The very first one, the smallest value, is going to be my negative value. Then I'm going to have a value of 0. Then I'm going to have a value of, let's see, 2/5 is smaller than 3/4. So there's the next one. There's the next one. There's the next one, and there's the last one. So there they are listed in increasing order. All right? So just make sure that you show your work and that you can answer those questions. All right, so we have one more, or we have a couple more problems here. I don't know that I'll get all the way through this one, but we'll at least get started, and then a second video will finish it up. Here it says, let P of x be f of x times g of x, and q of x is f of x divided by g of x, where f and g are the functions whose graphs are shown. First, they want us to find p prime of 2, and then q prime of 7. So the first thing that we're going to do is we're going to find p prime in x, because p of x is f of x times g of x. That is the product rule. 1 d2 plus 2 d1. And they specifically want it for x equal 2. So I'm going to show them that I realize p prime of 2 is the output of the function f at 2 times the slope on the function g at 2 plus the output of the function g at 2 times the slope on the function f at 2. So now what I've got to do is find all 4 of those pieces. Okay? Again, the first thing that we do when we go and look at our graphs is I want you to find the axes. I want you to figure out what your tick marks are and label those. Okay, and now we can go about answering this question. The output of the function f at 2 is 3. The slope on the function g at 2, I could use these 2 points right here. We have a rise of 1 and a run of 2. So that slope's 1/2. The output of the function g at 2 is 2. And the slope on function f at 2 is 0. So p prime of 2 is 3/2. I'm going to stop there. I'll pick up in the next video and we'll answer part B here, and then there's one more example. So look for that second video.